for housing construction. They want to check whether the quality of house is good or not. They can use this attribute control chart. You just go and check, is there a crack or no crack? Or you can decide how serious is the crack. Is it minor crack? Is it serious crack? So the decision is either to say it is pass or not pass. Or you can say this is poor, this is bad, or this is good. Okay, so this is attribute. Okay, so let me share with you the books. I'm going to follow this, your ebooks. Please read ebooks. Actually, your book is quite good and comprehensive, useful for those who want to implement SPC in your workplace. So keep it the ebook. You may need this example. For example, if you become quality engineer in your workplace, or you want to get, for example, more knowledge about Six Sigma, okay, this book is going to be useful, especially related to control charts. Provide detailed theoretical foundation of the methods. Okay, so this is okay. Do you see or not? Okay, let me check. Do you see this? What I'm sharing? Okay. Yes, thank you, Zahir. Okay. All right. So this control chart chapter 7. Okay. Control chart for attributes. As I say, attribute in, okay, in Malay it is sifat, sifat, ciri-ciri. Okay. Sifat. Or we can say we want to decide, is it good or bad? Or we want to say that it is accept or reject. Okay. Or we want to say accept or reject. Okay. So there is no need to have expensive equipment to measure. Normally, some organization they use attribute control chart before the variable control chart. Okay, so this could be a good starting. Okay, you start with attribute because attribute is simple control chart, and then we move on to, you start with attribute control chart. So this is what some company are doing, and they use attribute control chart because it's cheaper to implement attribute control chart, and then they move to variable control chart. Okay, then they go to variable. What are variable control chart? X bar chart, R chart, okay, multivariate control chart, and all those are variable control chart. There are also multivariate attributes. Okay, there are also multivariate attributes, but what we have discussed so far is multivariate variables control chart. Okay, giving numbers. So we have discussed this variable control chart, which is, as I say, more require mathematics there, more difficult compared to attribute control chart. Okay, so you should be able to understand attribute control chart easily after understanding variable control chart. Okay, so this is what I'm going to cover in these topics. Okay, so control chart, we say that control chart for fraction of non-conforming, fraction non-conforming. Okay, and we also have non-conformities. Okay, non-conformings and non-conformities. Okay, non-conforming, non-conformities. There are different meanings. Non-conforming, ing here. Here is tis. Okay, make sure you are able to understand this. Okay, please jot down in your whatever notes that you have. Non-conforming and non-conformities are not the same. Okay, non-conformings sometimes also called as defective. Okay, defective units. Defective Okay, defective units. Okay, non-conforming units. Okay, sometimes called also non-conforming units. Okay, when you have defective unit, it's same as non-conforming unit. Another control chart is, we call it non-conformities. Okay, control chart for non-conformities. This is referring to defects. Okay, so defects and defective in terms of SPC terminology, they are not exactly the same. Okay, so you can have several defects, but you can only have one defects unit, one defective unit. Okay, so non-conforming, non-conformities, defective, defects, you need to have that clear understanding. So if you still not understand at this point, no problem, but later on after this class, you should be able to differentiate. Okay, so in this ebooks also mentioned defective, or the other opposite is non-defective. Okay, the point here is keyword is defective. Okay, non-conforming, okay, conforming or non-conforming. Okay, conforming means good, non-conforming means bad. It's not passing the requirement. Defects, okay, defects mean good. Defect mean bad products. Non-defective mean good products. Okay. Right. So control chart. So for non-conforming chart or effective chart, okay, we have what we call it control chart for fraction non-conforming. Okay, fraction for non-conforming. So we are dealing. There are also chart. Okay, let me just highlight here. Fraction non-conforming. This is known as P chart. Okay, P chart. I hope that you prepare. I mean, make your own notes. If listening without any notes written, just you will forget it. Okay, so just waste your time. So you just at least you write something. P chart. Okay, P chart is a chart for fraction non-conforming. So P, why we call it P instead of saying F for fraction? P is proportion. Okay, proportion or nisbah lah. Okay, proportion. So you have proportion, yeah, proportion of fat products, okay, over the total products or total units, okay, over total unit that you inspected, okay, of proportion. Okay, P means P chart, proportion chart, okay, or fraction, okay, fraction chart, fraction non-conforming. Okay, there are situations also we're going to look into, we call it defects, okay, or non-conformities. Okay, so defect non-conformities is we use C chart. Okay, we use U chart. Okay, and also we're going to look into demerit chart. Okay, demerit chart also under category of non-conformities chart. Demerit. Okay, demerit. Sometimes in some books they call it D chart. These are three charts that we're going to look, okay, under this category of defects or non-conforming. Okay, under the category of non-conforming, here you have P chart. Another chart is we call it NP chart. NP chart. P chart is proportion and P is just a number of non-conforming. Number of non-conforming. Okay, number of non-conforming. I mean, just counting the numbers of non-conforming. So this is NP chart. If it's given in terms of proportion or fraction, we call it P chart. Okay, so this is non-conforming. Another chart is non-conformities. Okay, non-conformities. All right. If you want to know how to differentiate between these non-conforming and non-conformities, non-conforming is given in terms of number of units. Okay, number of units non-conforming. If it is given in terms of C chart or U chart, okay, it's referring to per unit. Okay, per unit. The example is non-conformities per unit. Okay, or count of non-conformities. It is C. C is referring to count. Okay, U is considering as a ratio of non-conformities. Okay. All right. So this part, I think the objective of this chapter, you should be able to read on your own. Okay. We want to know is P chart. We want to know NP chart. We want to know C chart. We want to know U chart. This is the purpose of this chapter. Right. I think I can go directly to P chart now. Okay. So it is the theory of, the theoretical theory of this P chart, okay, or we call it fraction non-conforming chart. Okay, it is coming from this, okay, the probability of having, okay, the defective, okay, is given by this, okay. D is a binomial distribution, okay, following binomial distribution, okay. So the non-conforming units is, okay, the event happening of non-conforming is following binomial distribution, okay, with N and P. Okay, N is how many, the numbers, and P is the fraction or the proportion. If you see here in this formula, okay, on this part of the formula, okay, if you study statistics, so this is the proportion of that X, okay, the number of defects that are happening. P, after that you have 1 minus P, meaning at the opposite of it, okay, N minus X. Okay, don't worry so much if you're not really clear to you for that, because the formula we're going to use later on is very simple. Okay, so just understand that proportion, or we call it estimate of the proportion. Okay, this is the estimate of proportion, which is D equal to P cap. This is estimated values, equal to D. Okay, D is the variable D is defects. How many defective units? And divide by how many numbers of units or the sample size that we inspected. So this P equal to D over D. Okay, and the mean. Okay, the mean of how many defects is just the averages of the P. Okay, so this is the mean. Okay, and this is the variance. Okay, the variance. Okay, the variance is square of standard deviation, P1 minus P divided by N. If, let's say, P is equal to 2 over 10, which is, let's say, you inspected 10 units, 2 are defective. Okay, defective unit. Let's say this is the D, is 2. Okay, this is where you inspected N, equal to, the sample size is 10. So your P will be 0.2. Okay, so 1 minus P, just 1 minus P in the bracket is just going to be 0.8. Okay, just simple as that. Okay, so sometimes people call it PQ, Q equal to 1 minus P. Okay, divide by 10, N is 10. So this is the variance. Okay, standard deviation square, meaning the variance of P chart. Right, so that is the foundation of the chart. So when we develop this P chart, okay, as usual, we still have to have the central line, which is, okay, going to be P bar. Okay, central line is P bar. The top line will be, okay, you're going to have P bar plus, okay, as usual, you're going to have 3 standard deviation, okay, with, okay, standard deviation of the P. Okay, same also at the bottom here, P bar minus 3 standard deviation of P. If you look at here, P bar here is given as mu. This is just in the mean, the mean. P bar is the mean. Okay, we are focusing on the mean of the P bar. Okay, is the mean. Okay, don't get confused. Sometimes different symbol is used. Mu mean the mean. Okay, or we can use P bar for the P chart, and we use X bar for X chart, X double bar for X bar chart. Okay, and we have here 3 sigma. So here is put as L. Actually, this is just a limit. And normally we are using for control chart, we use 3. And we got sigma there. Okay, sigma is, I put it sigma P for P chart. Okay, so as noted here, L is equal to 3. Okay, L is equal to 3. Now, this formula, okay, is for the purpose of P chart. Fraction and conformity chart is known as P chart. Okay, known as P chart. See the central line here, P. Okay, so depend on the book. Sometimes they put it P bar. Okay, they put it P bar because we want to take the average. This is P bar. So I put it here. Okay, different books sometimes use P bar, okay, which is P average. Okay, here is P bar plus 3. Okay, this is actually the sigma. Okay, this is the sigma P. Okay, if you get this cap here, meaning the estimated values. Okay, so P1 minus P divided by N. Oleh kerana because of this is taking from variance, okay, you got it square root. Okay, square root. If you see here, this is square. This is the variance. Okay, the variance. So this is the variance. So because we want to have only standard deviation, we just square root of this P1 minus P divided by N. Okay, so that's all the chart for P chart. Okay, let's see example. See here, this again, they show it P bar. Yeah, this is a formula that normally we use P bar. Okay, the one that I just mentioned, P bar plus 3 square root of P bar minus. So this is the central line. Okay, central line. So we use this formula. Okay, this is the formula that we're going to use most of the time. Okay, this control chart is often called P chart. Okay, we can also have the same situation as X bar chart, where we have the trial control limits and we can have revised control limit. Okay, we can start with trial. Sometimes people call this as phase control charting. Trial control chart, which is require you to find control limit, trial control limit. After knowing the problem of the control chart, okay, I repeat again. Normally in beginning of any control charting implementation, people produce trial X bar chart, trial S chart. Okay, because normally beginning of process is not stable. After knowing the root cause of the process instability, okay, we investigate the process, we stop the process, we identify the root cause, we eliminate the assignable cause that we have identified, and then we remove those out of control data, okay, and then we use the revised control limit to monitor the future process. If the process still not stable, we revise it again. But for the purpose of this class, most of the time we just assume one-time revision is enough, and then we get a new control limit. The new control limit is assuming coming from a stable process, and those revised control limit is used for monitoring future process. Those are phase 2. Okay, this is, we call it phase 1. This is applicable for all the charts. Variable control chart, attribute control chart. Here we start with trial. Okay, this is phase 1. Some books, they call it phase 1. Okay, you see here, phase 1. Okay, phase 1 aspect. And then we go to revised control chart. Okay, revised control chart. Applicable to all the charts, not only for P chart. So this is called as phase 2. Remember, you only can revise after identifying the assignable cause. Assignable cause has been identified, and we are able to remove the root cause of the problem. Don't revise control chart if you are not able to identify the root cause of the problem. The root cause of the problem can be the cutting tools has loosened. The cutting tool telah longgar, ataupun the cutting tools has broken, or the cutting tools have worn out. Okay, maybe some material required in the process as depleting, not enough. So you need to resetting again. So those are the things, and require operators to go and reset the process after removing the root cause. If we do not remove the root cause, we go and reset, the problem will be recurring. Okay, this is what we call it suppressing. Okay, suppressing the root cause. And in the past, control engineering, I'm sure you have learned about control engineering. Some people might be confusing. We have SPC control, we have control engineering, statistical process control using control chart. Okay, SPC. And then you have maybe engineering control. Okay, you study engineering control feedback. Okay, feedback loop and so on, where you find the error. Okay, so this is, we call it engineering controls. Okay, so the limitation in engineering control is that the root cause is being suppressed, meaning that the root cause has not been eliminated. You just go and reset the process. Okay, but SPC identify the root cause and eliminate the root cause, okay, before proceed with the process. So these two areas, SPC and engineering control, now are merging together. Okay, so this field of study where SPC is developed by industrial engineering, statistician, and so on. Engineering control are developed by those control engineering. Okay, so now they come together. They are getting together using SPC to guide engineering control to remove the root cause before allowing the process to continue. So they get together. In the past, they are not together. Okay, so now they become synergy, and the process become better because control engineering diagnose the root cause of the problem together with SPC techniques, eliminate the root cause, and process can be more sustainable for future monitoring. Okay, let's see the example here. Okay, if you have problem understanding, please let me know. Please ask, because I don't see you. Okay, so we want to make sure that you follow the class. If there is having difficulty, let me know. All right, let's see example number 1, construction and operation of fraction non-conforming control chart. So this is basically P chart. Okay, this chapter, this example is showing P chart. What is P chart? Proportion. Okay, proportion. All right. In this case, okay, I let you read first. Please read. I will ask you. Please read, because reading, actively engage in study more effective rather than just listening passively. Okay, read this. What is the problem? I want you to explain this problem. Just read. What is the problem here? Okay, just read this problem.
Arthur, let me do.
Yes, okay. Boleh?
Okay. Sorry. Frozen orange juice concentrate is packed in 6 oz cardboard cans.
Ounce, 6 ounce.
Sorry, 6 ounce cardboard cans. These cans are formed on a machine by spinning them from cardboard stock and attaching a metal bottom panel. By inspection of a can, we may determine whether when filled, it could possibly leak either on the side seam or around the bottom joint. Such a non-conforming can has an improper seal on either the side seam or the bottom panel. Set up a control chart to improve the fraction of non-conforming cans produced by this machine.
Okay, very good. Okay, the word used here is non-conforming. Okay, here also non-conforming. When you see the non-conforming, it's referring to P chart. Okay, if you say non-conformities, cannot necessarily or not directly imply it is P chart. Okay, but it's non-conforming. Okay, if it is saying that non-conformities, most likely it will be C chart or U chart. And when it says non-conforming, okay, non-conforming cans, okay, non-conforming units, so it's that clearly show that it is P chart. Okay, sometimes they don't say construct control chart, they just say set up control chart to improve fraction of non-conforming. So we know that fraction is P chart. Okay, so you need to understand that the chart is simple, but if you misunderstood that, okay, everything is failed. I mean, wrong lah. Okay, so this is inspection of orange juice. Okay, orange juice concentrated in 6 ounce. Okay, they use it. This is American units. They don't use metric system. Okay, so it's going to be machined by spinning them in a cardboard stock and then attaching metal bottom panel. Okay, so they are doing the inspection. Okay, this is not measurement, they just do inspection. Inspection either to say is it good or is it bad. Okay, and then either to see is there any leaking or not. Okay, on the side seam. Okay, or around the bottom joint. Okay, so basically this is packaging lah. Cardboard, okay, cardboard can. I think maybe a drink. Sometimes you have this drink lah. Can drink macam air kotak kan? I think something like this lah. Okay, the packaging, and then you want to see the quality of this packaging of the air kotak. So they say establish control chart. You need 30 sample. Okay. Okay, in this case it's 30 sample, and then every you need 30 sample. Okay, sometimes we refer this as subgroup lah, 30 subgroup. Okay, 30 subgroups. You have subgroups, 30 subgroups, and every subgroups the size is 50. Okay, 50. Okay, so it is selected half an hour. Every half an hour we select that. Okay, over a 3-shift period. Okay, 3 shift in which machine was in continuous production. So the machine is running continuously. If machine is stopped, you have to be careful because now the stopping of machine may affect the data that you collected. Okay, let's see table 7.1. Okay, this is a table 7.1 where it is running for 3 shifts. Okay, you have number 1 to 16 here, and you have 17 to 30. Okay, let's say 3 shifts working a day. One day is 24 hours, maybe shift number 1, 8 hours, shift number 2, 2 hours, 8 hours, shift number 3, 8 hours, to altogether 24 hours running, 3 shifts. But machine is running continuously. Then this is very important statement. The machine is running. Machine is continuous operation. Okay, maybe 3 shift is for the workers to look at the data. Okay, but no interference in the process. So number of non-conforming cans is given by D1, number of defective units. Okay, 12 can, 15 cans, okay, 18 cans, I mean 18 box lah. Okay, 10, 4, and so on. So to get the fraction, we just get it 12 divided by 50. Okay, this number is coming from, okay, D divided by N. Okay, so we have 12 divided by 50. Okay, so this is what this column is showing. Okay, so 15 by 50, so you get 0.30 and so on. So this value is actually the P values. Okay, this value are the P values. Okay, this value also P values. Okay, so because the formula that we have require the P bar. Okay, remember that we need to have a P bar. This is P bar. So the total of defective unit is 347. Okay, M is 30, N is 30, okay, 50, sorry. So this is that. Okay, the total of D 347. Okay, you total all this. Okay, total all this, you get 347. And then we need to get P bar. Remember in our contour chart, we need to have the central line. Okay, this is central line. The averages of P. Okay, this is central line, which is P bar. Okay, you can take the averages of the P bar here, add all this, divide by okay, divide all this together with all this, divide by 30, or you just use this formula, also can. 30 subgroup multiplied by every subgroup have 50. Okay, total defective unit is 347, you will get 2317. So this also can be done like that. More accurate like this lah. Okay, this way. But if you add all these numbers, okay, if you add all these numbers also can, but that might be some rounding off, rounding up numbers may affect the decimal point. Okay, you add all this, divide by 30 also can. Right, so we have the central line. Now you have to get the control limits. Okay, control limit. So just plug in the numbers, the formula. Okay, very simple. You just plug in the numbers into the formula. So we have this P bar. Okay, P bar plus 3. Why 3? Because 3 is sigma. 3. So the sigma is given by square of P bar 1 minus P bar divided by N. So all the numbers already available here. Okay, just put it here. P 1 minus P, and remember the denominator is the N. Okay, the N of each group. So in this case, N is fixed. So you are measuring N of fixed numbers. So every time of sample number, we get the N equal to 50. So solve this, and then this is what you get for the upper control limit and lower control limit. Any question up to this point? Okay, if you have problem with your mic, okay, you can put it in your chat box. If no problem, I continue. Okay, so now we plot. We plot the central line. We plot upper control limit. Okay, one thing that I need to remind you here, lower control limit in P chart is not so significant because actually lower P or lower control limit, meaning that the process is improving because proportion. If we have low proportion of defective unit, I mean the process is good. Okay, the process is good. So we are just concerned most of time is upper control limit. Okay. Sometimes you may have lower control limit that become negative. Okay, lower control limit of P, if it turn out to be negative, okay, you can change this value to become 0. Okay, become 0. But we don't pay so much attention on the role of lower control limit in P chart. Okay, because lower P meaning better quality. Okay, because it is a fraction. So in this, the one that you have seen just now, we have 2 points outside control limit. Okay, so of course we can also look into the pattern and so on. But for the simplicity, in this case, we see that okay, these 2 points outside. So this process has to be investigated. Okay, if we want to go deeper, we can also look at the pattern like what we did for X bar chart. Okay. All right. Okay. Okay. So I think this problem continuing that they have to do something here. Okay. 2 points. Because 2 points outside, it was saying that. Okay. Sample number 15 and 23. Okay. 15 and 23. Sample 15 and 23. Okay. It is outside control limit. Okay, this is 15 and this is 23. So it means that this control limit, this control chart cannot be used for monitoring the future process. So what we have to do, we have to stop the process. We have to stop this process and look into what happened. Okay, what happened on sample number 15 and what happened to sample number 23. Okay, this point must be investigated. Okay, please take note this. These 2 points must be investigated, whether assignable cost or not. Okay, whether it has assignable cost or not. What is assignable cost? Assignable cost is a problem, okay, to the process. It needs to be eliminated. If we say non-random cost, meaning there is no problem. Non-random cost, random cost. Okay, random cost is no problem for the process. Random variation is always there. Okay, so you still remember whatever happening within the control limit for a normal process, a stable process, it is because of random variation. Okay, in general, assuming pattern is not relevant in this case, assuming, so we can say this is random cost. If random cost, process is okay. Okay. If this is attributed to non-assignable cost, okay, assignable cost, which is we are having now 2 points here, it is a problem. We need to investigate this. Who caused the problem? Is it operator mistake or is it machine has deviated from the standard setting? We have to investigate. After investigation is done, okay, in this case, they found out. Okay, they found out what happened. They found out that sample 15 new batch cardboard stock was put in the production. Okay, so they mix up the material. So new production, new sample was used there. Okay, the introduction of new batch of raw material caused irregular production. Reasonable to believe that this has occurred here. Okay, during half an hour in which sample 23, inexperienced operator has been temporarily assigned. So sample 15 and 23 are eliminated. And the new center line and the revised control chart are now being introduced. Okay, so we have to calculate P bar new. Okay, this is representing P bar new or revised P bar. Okay, sometimes you can see the symbol people use like this, P note, okay, to represent P bar new. okay, or P bar revise. Okay, you get this. Now from 30 become 28. Okay, because why? Total 30 subgroup. Now 2 subgroup is out of control. You have identified the root cause. We can eliminate that 2, and now become 28. Okay, become just 28. Okay, 28. Multiply by 50 because every subgroup have 50. So now you get a new line, new control limits. Okay, and then this control limit can be used for further monitoring. Okay, this is same as what I've shown just now. Okay. All right. So if we see here, okay, if you see there, the revised now smaller values. Okay, smaller values now. You have the revised control limit 0.3893. This is 0.0. So this is one more point outside. Okay, but we don't remove this because the removal was based on the original or the old. I mean the original data. Okay, so this is we try to plot to see what happened. This is a new one, the new revised. So when we put it, actually there is another point, but we don't do anything for that. We take the process from the data from new process and we plot it again on the revised control chart. Okay, this is just to show that actually this point also affected, but we didn't remove it because originally the upper control limit was 4.4102, 410. So it was somewhere here. Okay, very close to the control limits. This one, very close. Okay, very close. All right. I think I give you 10-minute breaks. Okay, before I proceed. Is it okay?
Okay tak?
Alright. Orang lain semua senyap you seorang ni ada dalam kelas ni. Orang lain buat apa Okay, we have 45. Alright, so 10-minute breaks. Okay. Okay, thank you, Nur Ain. Jannah. Okay, for your reply. Right. Okay, so we have seen this how that P chart can be used, okay, and also can be revised before we proceed to use the control chart for future monitoring. We revise for future monitoring.
Doktor, nak tanya sikit, tak sempat tanya tadi. Untuk yang revise control, sebenarnya kita still guna 30 ataupun kita guna yang barunya 28?
28. Okay, this is okay, this control limit which is smaller. Normally when we revise, we get smaller. This control limit actually based on 28. Okay, 28. So you get a smaller limit lah, basically. If we keep revising, okay, we're going to get smaller and smaller. Okay, because why? The process get improving. Okay, smaller and smaller. Every time you revise, you will eliminate the cause of the problem. Okay, so normally dia akan semakin kecil lah. Okay, so but when you implement this control limit for the new data, okay, use new data. But in this case, they use the old data, same data, just to show that how this new line, okay, with respect to the old data. But here is you have to collect new data. Okay, collect new data, but using the revised control limit. Okay, revised control limit kat sini based on old data, but remove data which is outside control limit. Okay, we revise the control limit by eliminating this point. Okay, you get a new. Sorry, this one tadi dia datang dari sini daripada yang lebih besar kan. Datanya lebih besar. Okay. So after this one remove, you get this line. Okay, and then you collect new data. Okay, collect new data. Sorry, this is not good example. This is not a good example. But actually what I'm trying to say is this line, okay, actually this is not a good explanation here. Okay, let me just don't relate to this data. But in general, it is correct. When we revise, we always keep getting smaller control limit, meaning that improve quality. Okay, quality improve. Quality of product improve. Because it is more, what you call less variability. So what I'm trying to say is, you have this data. Okay, let me just go back to this. Okay, this one. Go to this one. So we know that this line, this control, this process, we say this process unstable. Okay, we can say that process statistically. Okay, normally we say process statistically unstable. Okay, we put statistically because this is based on sampling. Okay, process statistically unstable. Okay, what we do, we revise. Okay, we revise. So we revise the control chart. Revise control chart meaning that you're going to have a revised control limit. Okay, control limit also might be slightly lower because we are now removing the apa ni yang unstable tadi kan. Okay, so you may also have this a new line. Okay, so this one now you have this after you remove this. After you remove this, you get this control chart. Okay, which data that you plot on this chart? Okay, new data. Okay, you plot new data. Okay, actually we don't plot the old data on this, but the book was showing that plotting the same data just to show relative changes lah. Okay, plot new data, new collected data. Okay, so this is where we are monitoring, because we are monitoring the process. As we move on, we compare with the control limit. You cannot wait to use the new control limit for future process because the process is running. Okay, so the new data being plotted against the revised control limit. Okay, let's say one point is outside again. You will stop this process. Okay, and what you do? You revise it again. If knowing that this point is assignable cost, okay, you revise again. Okay, you will revise again. Okay, maybe this time you get more improvement because the process, the root cause of the problem has been improved. And where, okay, this is control limit. I put the CL, control limit. So where do you use this? You use this for future monitoring. Okay, for future monitoring. So when you run the process, okay, you collect data and you compare, okay, the new collected data with the revised control limit. Okay, to compare. Faham kan ni? How the control chart can be used? Is it okay?
So maknanya doktor, yang benda yang akan berubah hanyalah control limit saja. Maknanya sample number kita still guna sampai 30.
Yes, yes, we collect again 30. You collect again 30 and then you revise lah. Okay, so the G will be another 30, the new one. Okay. This is G30 kan, the group. Okay, the sample number lah. This we call it sample number 30. But this control limit is based on 28 because 2 point outside ni. Faham kan? This control limit, the control limit that you prepare kat sini, it is coming from 28. Okay, because you need to use this control limit for future monitoring. Okay, to monitor from future monitoring, because we need to have control limit for monitoring the next process. Okay, let's say ada 3 ataupun ada 2 lagi, mungkin ada 4 yang outside. So this control limit will be 30. Okay, based on 30 tolak 4. Okay, in the formula here. So the formula here, you need to remove. Okay, you need to remove 4 kalau dia 4 lah. Okay, you need to remove okay, this point. So this point adalah okay, going to be 30 minus 4, if there is 4 lah. And this one pun kena buang lah. How many yang outside tadi? Okay, so you remove all the point which has been related or associated with assignable cost, and you get a new center line. Okay, you get the new control limits. This is applicable for all the charts, not only P chart. Not only P chart. So we discard all the assignable points that is related to assignable cost and revise it. Okay, is it clear?
Clear, Doctor.
Okay, but whenever you want to use this, whenever you want to use the new control limit, you still have to collect 30. Okay, you still have to collect 30. And then dapati there are few points outside kan. You remove the point outside in order to produce a new one, a new control limits. But when you use the new control limits, you still collect 30. You still continue 30. And then after 30, only then you enough data to revise it again. If there is still any points outside control limit. 30, it is a good numbers lah. But if you say that 30 is too many, let's say you start with 20, kg equal 20, also can. But minimum lah, this is the minimum number. 20. When you go to here, also G equal 20. Over here also G20, meaning that you still have to collect 20. But when you want to revise, okay, you remove whatever numbers of outside. It could be 3, it could be 4. Manakala 20 tolak 4 lah. Jadi akan jadi 16 kan. So but it is small number lah. More number, it is better. Alright. Okay. So please go through this. And also there are situations where sample size is not consistent. Where sample size is not consistent, okay, the case of where sample size is not consistent, okay, let me see whether do we have this case or not here. Okay, if there is sample size not consistent, we have to use the individual, okay, individual control limits. Like the case that, here, we have it here. Okay, the example here is variable sample size for MP chart. Do we have example for this is this is P chart. This is P chart. Yes, this is P chart. Okay. Okay, this example, okay, page QSW12D1, everyone. This is non-conforming fraction, non-conforming with variable sample size. Okay, we have P chart. Okay, but in this case, N adalah variables. Before that, N was fixed. Okay, when N is variable, of course, very tedious. But if you have software, the software can handle the calculation. Okay, you see in this example 7.4. Okay, 7.4 ini adalah referring to data. Okay, on this table. If you see your sample size, we have sample size of 25. Okay, this case sample size of 25, meaning that the subgroup lah. Okay, the subgroup 25. Sample size changing. Sometimes 100, sometimes 80, sometimes 100, and then go to 110, 90. So you have variation of this control limit. Okay, so your N1, okay, ada 100. So mana satu control limit for 100, and then ada juga yang 80. Okay, ada yang 110, ada yang 90. Okay, ada 120. Okay, so N keep changing. Okay, these are the D, and this is the fraction. I think this P1 D over N is simple lah. Okay, and then this one also, now you have to change this. Okay, this formula require every time is different N. Okay, we have to use different N dalam case ini. Okay, but dia punya P and 1 minus P is fixed lah. Okay, and then every time there will be a new upper control limit and lower control limit. Okay, so okay, so you see here. Okay, this is standard formula. Okay, standard formula. The only thing that we have to be careful is here. N for each different N will be different. And this is example of control chart for fraction and conforming with variable sample size. Okay, in this case, N is variable. So meaning that every sample it will have different control limits. Okay, very tedious manually. You see here, sample number 1, this is the control limit. Okay, sample number 2, sample number 3, you see different. Okay, different. But actually no problem if the case are very far, but the problem might be happening. You have to pay special attention the case of like this. Okay, because it is borderline case. Okay, borderline case. So every point has their own control limits. Okay, this is using software. Okay, the software will give like this lah. Minitab. If you have many tabs, the calculation will be automatic lah. Or so another way of solving variable sample size is we take the averages. Okay, average sample size. You see just now the sample size are different. Okay, what you can do is take the N average. Okay, take N average instead of N individual. Okay, take N average. So what we have it here is only one line. Okay, so this is based on N average. We just take the average for N values and we plot only one line. But the disadvantage of this method is, okay, like I say, in this case, we have to pay attention to this issue of borderline case. In this case, nothing need to be done because it's individual already. We know that this point number, I think number 11, this point. Everyone follow me or not? Okay, this point, because it's individual, It's outside, right? Outside. So this, I think, number 11, number 11. But if you see here, number 11, okay, sample number 11. What do you see now? Sample 11, using an average instead of individual n. Can anyone?
Below control limit.
Below control limit, right? This is based on an average. Okay, n was 98. Okay, remember n is sample. I mean the number in the subgroup lah. Okay, we take 25, but every one of the sample different values. So to get the n average, we use this formula. Okay, we combine all the points here. You join all the points. I mean, you take the total of this. Okay, take the total of all this. You get 2450. This is 2450. 2450 divide by 25. Why 25 sample or 25 subgroup? And then it gives us 98. Okay, 98, meaning that instead of 100 in the RAT, we just use one n values. Okay, it is 98 in this case. Okay, this one 98, and this 98 is used in the calculation here. Okay, so get a new values. So the problem is when there is a borderline case. If the case is like this, no problem. Case which is very far. Okay, like this case. This case, no issue. Okay, no issue because it's very far from here. But the problem is when there is borderline like this. Okay, we see that if we use average, it is in control. But actually, this point 11 is out of control. How do I know out of control? I know it because when I refer to individual, it is out of control here. Okay, so we can use average to save our time, but we need to calculate individually the case of when the case is close to the borderline case. Okay, we can use an average. Okay, we can use an average, but we need to be careful when there is borderline case. Okay, that is precaution. Okay, when compared to the exact control limit, the point indicate out of control. Okay, so what it says that care must be taken in interpretation of point near the approximate control limit. So we have to be careful here. Okay, we have to be careful here, not just blindly use. We need to be careful when there is borderline case here. So we need to calculate individually. Okay. So that, I think that's enough for P bar chart. I mean P chart. For P chart. Okay, I would like to stop there for the contour charting. I would now to move on to discuss about group projects. Is there any question before I move to group projects explanation? Anyone has problem understanding what I've discussed? Or maybe let me try. Let me try to check whether you are following or not. Okay, Faiz. Okay, Faiz, what you learned so far today? Faiz? Okay, Fatimatul. Okay, what you have learned today? Ada tak orang ni? Okay, Julian, what you learn? Okay, surprising, no one responds. Okay, Muhammad Zikri, Aryaden.
Yes, Doctor.
Okay, what you have learned today?
About confirming p-chat.
Okay. That's all? Okay, I would like everyone, please write down in the chat box, okay, what you have learned today. Just put keywords, okay? What you have learned today. Please everyone, I have 41, so 20%, 20 students missing. Okay, non-conforming and non-conformity is very real, okay? Correct? Anybody else? P-chart, contour chart for attributes, okay, Muhammad Kamil. So far, okay, in this course for a group project. Okay, let me explain what is a group project. Okay, let me take the group projects. Where is my PowerPoint? I put it here just now. 2022 it should be somewhere here. Yep, got it. Yes, is it the one? Yes, I think so. Okay, let me share. Okay, everyone, do you see?
Nampak, Doktor?
All right, good. Okay, so this is the guideline for group projects. Okay, so this group project require you to prepare a report and also to make presentation. Okay, the presentation can be recorded presentation. You can send it to e-learning or you can upload to YouTube. Okay, so we require about 10 to 15 minutes presentation. Okay, at the end of semester. If you request to have a live presentation, also can. Okay, I give you choice. You can present it online directly to the class, or you can record and upload to YouTube, or if you want to upload to YouTube, or you want to upload to e-learning, also can. Okay, so I have done this before. It's not new things. Okay, so it's possible for students to do it. Okay, right. So you need to do. Okay, so this outline, of course, you can see in the e-learning, it's already there. So we have course learning outcome. Okay, course learning outcome. Okay, so this is what we assessment method. Okay, T mean test, F mean final. Okay, test and final. So this PR mean projects. Okay, projects. This is projects. Okay, so for this project, we would like you to look into this CLO2, CLO3, and CLO5. What are these? This is using the basic SPC tool. You have learned this, basic SPC tools. Okay, and you also learn about contour charts, okay, contour charts, and also process capability, which is CP, CPK, and also analyze group project in a given topics related to material cover in the class. Okay, So we are looking to this aspect of application, okay, of what you have learned. Okay, so you don't have to do all the tools that you have learned, but select that tools. Okay, select that tool. Okay, that is general. We have this in our course outline, the things that we need to address. Okay. Okay, how to move on? Cuma tak gerak ni. Okay. Okay, so this is also from the course outline. Okay, so you require, especially we are on CLO 5. Okay, CLO 5 meaning that analyze group projects. Okay, analyze group projects in a given topic. So and make oral presentation. Okay, this is what we need to satisfy for the course. You will have group projects. Okay, and oral presentation. So you require independent learning, non-face-to-face. Okay, it's allocated 15 hours. Okay, to use this. So meaning that outside the class, you have to get together in your group. Okay, you can spend about 10 hours, you can spend about 15 hours. That is rough estimate. So if you have about, let's say you spend for 3 weeks, 3 weeks, if 15 hours, meaning that every week you spend about, okay, if you spend 10 hours, okay, let's say your group is a good group, work very fast. So if you spend it in 3 weeks, every week's about 3 hours, okay, spending on this project. Okay, 3 to 4 hours. Okay, so if you spend it 4 weeks, so every week, because this project will take about 4 weeks. Okay, about 4 weeks, 3 to 4 weeks. Okay, 4 weeks is the remaining time for the semester. So if you spend 4 weeks, so if your project is require 10 hours to complete, so every week you spend about 2.5 hours. So for the projects. Okay, so remember this is a group. Okay, a group project, so you should distribute it well among your friends. So if you spend about 3 hours or 4 hours per week, okay, on the projects, so it should be sufficient. Okay, you don't expect that you do for project and you don't sleep. We don't want that. Okay, so allocation for the projects. Okay, assignment and projects, okay, we allocated 20%. Okay, but for this project, okay, you should use what do you call it, appropriate number of hours. Okay, for projects, okay, I will evaluate only 10%. Okay, the other 10% is coming from assignment. Okay, you know that there are many assignments that I have given. Make sure you do that. Okay, this is, if you do it properly, you can easily get this 10%. Okay, for the group project is only another 10%. Okay, I also will consider marks for assignment and also class participation. If you don't participate in class, I cannot help you. Okay, I cannot help you. So you will lose the part allocated for assignment and for the projects. But for project, it will be group projects. But we want everybody to participate because it will be individual marks. Okay, it will be individual marks even you are doing it as a group. Okay, that's why in the presentation, everybody has to present your part, okay, your contribution to the projects. So the others, 20% here, 20% for a test 2. Okay, test 1 I will announce this week. I will release your marks. Okay, and the final is 40%. So this is in the course outline. If you go and look at in the e-learning, also we have this the course information. Okay, so what are the topics or possible topics that for you to do it? Okay, because of pandemics, we don't expect so much on the case study unless you have a case study that is accessible to you. But you can do also literature review, okay, and find a case study that has been used by others, make comparison and give your own comments. Okay, based on what you have learned, you say, I want to compare two studies that have been done by others. Okay, you make your own original comparison, but we don't accept totally copy from others. But if you make analysis of previous study, you can do it by comparing project A compared to project B that has been done by others, and you make suggestion how this study can be further improved. But if you take it 100%, just download and come and present, submitted a report to the class, we found that plagiarism, you get 0. Okay, plagiarism cannot be tolerated. Okay, so these are some of the topics. Okay, so we would like you to focus on Six Sigma. Okay, because the Six Sigma is basically combining many topics that you are learning in this course. Okay, you can have a topic, for example, application of Six Sigma for process improvement. Okay, you can give example of case studies that others have done, how they use Six Sigma, how they solve Six Sigma projects or Six Sigma problem using the tools and technique you learn in this class. Lean Six Sigma. Okay, for example, you can make a review on Toyota production system. Okay, combined with Six Sigma. And you give example, what companies have used this. A lot of resources available in YouTube, on online internet, in publication, in journal, you can easily search that. Comparison between TQM and Six Sigma also can. Okay, these are example of topic. Lean Six Sigma and Industry 4.0. Six Sigma and data analytics, Six Sigma and supply chain, Green Six Sigma, Six Sigma quality 4.0. Okay, Six Sigma and artificial intelligence, Six Sigma in product design. Okay, or you can suggest your own topics. Okay, but of course you need to consult with me to make sure it is okay, acceptable topic. Okay, review of previous related Six Sigma project and make comparison at least 2 previous Six Sigma project. Merely presenting other works without having your own input comparison is not acceptable. Okay, you can use Six Sigma to solve a case study problem. So it could be hypothetical or enhanced case study with a new assumption also can. Or critical review, okay, with example or application. So basically these are possibilities of the group projects. Okay. Any question? All right, students are required to work in a group, okay, to integrate quality and statistical engineering tool in solving case study. Ideally, we want you to see that you are implementing several techniques. Okay, not only control chart, but there are other techniques that you have learned, the fishbone, okay, the cause and effect that is used for solving quality problem. That's why we say Six Sigma, it is integrating. Okay, Six Sigma is basically the umbrella of many quality engineering tools, okay, and quality systems that you are learning. Okay, the marks will be 10% from the total course mark. Okay, interim, I require you to submit an interim report within 1 week. Okay, meaning that on Monday next week, I need to see the topics, okay, the outline, okay, what are your study, okay, what will be your references that you have reviewed. Okay, by next week, you will get 2% for the interim. Okay, and the other marks will be coming from report and presentation. Okay, you need to have at least 4 references must be included. Okay. Right, for the detail of written report, I will share with you later on in apa ni in what do you call this, apa, in Telegram, and also I will upload to e-learning. Okay, what you should put in the written report and what you should include in pro presentation. Okay? So at the end of semester, at the end of the week, that we're going to have about 4 more weeks, you must submit PowerPoint and recorded presentation to e-learning or provide YouTube link. If uploaded to e-learning, if you uploaded to e-learning, so meaning that if you have your YouTube, okay, some students submit to YouTube, they just provide a link. I mean, a notes on the address of the YouTube link. Okay, but letter submission is 2 February. Okay, 2nd February, which is about 1 month from now. Okay, so this assignment, the value is 10%. Okay, any question? You already know who are your group members. Okay, I already announced that. Anybody missing from the group, please let me know. I have not received any feedback after I what do you call it? I announced the group members last time. So I assume everyone has a member. It's belong to a group. Okay?
Doktor, boleh kami nak slide
Yes.
nanti?
Boleh. Okay, nanti saya sharekan dalam Telegram, and also I will share to your e-learning.
Doktor,
Yes.
saya tanya, jadi yang report tu dalam PowerPoint ke atau Word yang nanti nak buat?
Okay. Macam ni lah. I think because of your, okay, let me see. I have to satisfy this requirement. CLO5 says that analyze group project in a given topic related to material covered in a class and make oral presentation. So it didn't say about report. Okay. So I think since this is a special pandemic online class, to simplify your work, I think we can limit to presentation. So I can, whoever want to submit written report also can, okay, but the oral presentation is compulsory. Okay? So I know that some of you
buat
might
slide
be,
and
slides, yes, must submit PowerPoint and record the presentation.
15.
Present you record
10 to
because we
15
have
minutes lah.
Yes, 10 to 15 minutes for everyone. So everyone must explain. You see here, oral should cover your explanation, how you decide the topic, your group member chart, and how many meetings that you have. And then every member should explain how did you do your part. Okay, the personal reflection, experience. We do not want you just read textbook material. We want you to explain what your contribution related to the projects. Okay, so the PowerPoint can cover contents of your projects, but your explanation will be more on how did you do it. Okay, so since I give you discount lah, basically written report is optional. Okay, if you want to write a written report also can, so that I can see your contribution lah. But if you think that it's too much, okay, because this is online and then you have some problem with, I know that they are so stressful on online class, for some of you. So we can, compulsory is PowerPoint, okay, and record the presentation. So your PowerPoint must have detail about your projects, what you do, but your presentation, I don't want you just read whatever you have on the PowerPoint. You must explain your contribution. Okay, so this is to replace this written report lah. So your PowerPoint should have the content of the projects. Okay, when you present how you do it, not reading, not reading the details of the contents. Faham ke? If you don't understand that, you can submit both written report and the presentation. Okay, faham? So I give you a choice. You can submit report, okay, which is some classes are required that. Okay, you can submit report and you make a presentation. Okay, which is you recorded your presentation and some PowerPoint submitted. You say, okay, we have your group is so busy, you have so many other assignments to do it. You just prepare PowerPoint, okay, make a presentation, and your PowerPoint must be more details lah. Okay, what problem you have addressed, okay, what are the tools that you have used, what are your comments. So when you present, 10 minutes is not enough to explain all those in the PowerPoint. You will be presenting, explaining what is your part, okay, which part that you do, what approach that you have used, what references that you have used to do that, what is your comment. So I'm looking more on the process of you preparing that project. Okay, rather than you go explaining control chart is what is control chart, what is P chart, what is the IR4, what is ISO 9000. We don't want the textbook material being presented. We want to see your reflection. Okay, what are the problems that you face? What challenges that I put it here. Every member should explain how did you do part in the project, personal reflection, learning experience. Okay, what you have learned, what you dislike, what you like. Okay, your suggestion. Okay, your suggestion. So the presentation is this. Okay. The material in your PowerPoint can include the material of your projects. Okay, the explanation is we don't want you to read the PowerPoint. We're not sure whether you understand or not. But this explanation is evidence that you really do it your projects. Any question?
Maknanya doktor, dalam presentation tu, benda yang kita tulis dalam slide, tak semualah kita terang.
Yes, the slide can be evidence or you do it, but when you explain how you do that, how you, for example, make comparison between two techniques. But you don't have to explain the detail about the techniques now because those are standard materials. Faham ke? This is what you want to present, but in slide you have to have more detailed evidence that talk about the projects. Okay, so because we don't require you to produce report. Okay, if you think that you don't have enough time, but if you want to produce report, you will follow this one lah. Okay, this one. So meaning that in your projects you explain about the projects. Okay, what are the source of data you use? But you put the data there that from the references. In this case, you may not be able to go and collect data because pandemic has some restriction. So you take what others have done, you comment. Okay, this project by who? He has done this for Six Sigma implementation. And you say another project is done by Mr. X. They do this project in different electronic company. The other one may be in automotive company. You make comparison. You say this is a comparison that I've done. And in doing this, I use this technique. I faced this difficulty. I was not sure on this. I want to see that, your process of doing. But you don't go and read the data because this is not your data. Somebody else's data. Just explain this is the data. They use this technique. Faham ke? So this written report is optional. Siapa yang nak buat report, nak present pun boleh. But it is optional lah. Okay, as I say, if you choose not to submit report, your PowerPoint should be more detailed lah sebab you don't have report. Itu what I'm saying. But since you have only 10 minutes to explain, the selection of what to explain is following this. Okay, but in the PowerPoint and more detail, you're not able to explain everything within that 10 to 15 minutes. Okay, so when I want to see evidence of your project, I go back and see your PowerPoint lah. Okay, any more question? I think we have now 1 o'clock already.
No.
Okay, if there's no, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Doctor.
Okay, sama.
Thank you, Doctor.